Okay, hi folks. Thanks very much to all of you for coming along to hear these pitches. I'm really excited for this. So, in terms of a bit of background, Smarter Transport Systems competition was something we launched on the back of the Transport AI Action Plan. I think we're all really aware of the potential for AI to make a difference here in the UK to make the transport system more efficient and work together as a system. So we ran an innovation call with CPC to find the innovators who could make a difference in this. So we were looking for innovations in automating inspection, in predictive maintenance, in optimizing the network, in building resilience, and in making the system more inclusive. So that's what this challenge was all about. So here we are supporting innovators who are going to make that happen. So with me are the final 3 of more than 80 applicants who applied to this competition. There was a really high standard, and these are the guys whose pitches were chosen from the top 10 for their dragons. So we had 4 dragons, including a transport minister. So congratulations to these guys as the winners. And I won't say any more, but I'll let them show you why they're here. I'll hand over to Robert.
Yeah, I don't think I need that. Thank you very much, Asher. Hi, everyone. Are we on? Excellent. Hi, everyone. I'm Rob from TrackBase. We're a small SME of 12 people, and I can see some of my team have arrived in the corner, which is really nice of them. So I'm going to get rinsed on this later if it goes wrong. So we're a small SME. We build data-led tools for rail operations, performance, and timetabling. And here I'm going to present our solution, which we presented for the DFT around predictive maintenance stream of the Smarter AI in Transport Systems competition. So the problem is this. Rail asset maintenance currently is schedule-driven. It's not condition-driven. An asset may fail. We may go out to see an asset. But at the minute, asset inspection cycles are based on a series of 1 monthly, 3 monthly, etc. And when I say assets, I mean things like points machines, signal equipment, track circuits, things like that. The physical systems that actually keep trains moving. So at the minute, as I say, assets are inspected on fixed cycles. This is not based on how they're used or stressed. And we have a lot of information, actually, to understand how they are used or stressed. An example of this, a heavily used set of points, a freight-heavy route, can and likely will degrade much faster than inspected, and it could fail between inspections. So if you have a 3 monthly cycle of a points machine and you have a consist load which is very high running over that, chances are there is a risk of failure. And from our research, we understand that a third of delays currently in the UK are actually infrastructure related, hundreds of millions annually in Schedule 8 and Schedule 4, whether that's planned repairs of the track or unplanned disruption as a result. So we have this data. I think it's really important to say. Network Rail owns a lot of this data already. So you have asset systems like Ellipse and EAMS, operational data, TPI, telemetry data like radar data. And at the minute, the problem is it's not systematically combined. There have been asset programs where they've tried to combine operational data with asset data. But the main thing at the minute is, and part of our innovation on this is we believe we have a way to actually combine operational data from a new data set TPI into that asset data in a different way. And that's the gap. Previous data programs, to our understanding, have looked at this, but they haven't delivered this at scale in a new way. And this also aligns with DFT priorities around reliability, value for money in CP7, better use of data, and responsible AI. So the question I ask you all is, how do we actually use this data in a way which engineers can trust and act on? And that's a big thing, introducing systems into Network Rail, and we've got experience of it. You have to gain the trust of the organization, which is very difficult in many instances, and in particular around AI. Questions are asked, is this going to take my job? Are we going to move away from this? How do I know what it's actually doing? So the solution we've got, and I can't pretend to know too much about this, this is very much my chief technical officer knows everything about this, but I'll do my best, is a dynamic Bayesian risk model for rail assets. So this is something which can model the likely condition of an asset based on evidence available. So what we would feed into the model, telemetry data, asset characteristics, what the asset is, but very importantly, the operational usage data, which we now have in a system like TPI. So in TPI, for example, and for reference, it's Train Performance Insights, In that information, we have consist data. We know the loading characteristics of the train. We know the GPS data. We know when it's run up to a point where maybe it's sat on a bridge, for example, for too long. And the model updates continuously as new data comes in. As a result, the risk is always current. It's not based on static inspection windows, which may or not surface the risk. And Bayesian models work well here because they handle uncertainty really nicely. They evolve over time, and importantly, therefore, as I say about trust of the engineers, they remain interpretable. Engineers can understand why something is being flagged, and they remain the decision makers and the person in the loop. And the way we service this is a simple web app. It's a bit blurred, that version of it, but it's a simple web app. Engineers can review and act upon that. And the USP of this is the Bayesian model, which feeds into the web system. So the impacts of this, very straightforward. We can identify emerging failures earlier, reduce reactive call-outs, and a very important part, reduce no-fault-found inspections in rail. So we understand from our conversation with Network Rail that up to a third of inspections actually find no fault based on this schedule data. So they go out and inspect things, and then there's no fault, but it's based on the schedule they've got to follow. And we're not suggesting that that shouldn't happen necessarily, but we're suggesting it should be targeted in the way they do it. So this means better targeting of engineering time within existing budgets, not more cost, better decisions, and ultimately improved reliability, lower delay minutes, and better value for the taxpayer. This enables the shift from schedule-based maintenance to risk-based intervention, and that's the real step change. So our current plan at the minute and our integration route to market is as follows. So firstly, it's designed to be a low-friction system, using systems that Network Rail already own, and it's something that TrackBase we've really taken to heart. We do not believe that any supplier should own the data that Network Rail pays for via the taxpayer. We believe that we should support them in utilising their data in better ways. So, for example, Ellipse and EAMS, Radar and TPI. TrackBase is the supplier currently for TPI into Network Rail. We help them to develop it as a Network Rail-owned system. So we have that advantage of where we understand the asset, the operational data, and we also have experience working with asset data. Importantly, no new data infrastructure is required for this. The systems exist. We don't need new ones. This is very much a model. They can put it out here, and we can take the data that they've already got and push it through the Bayesian model. We're already a trusted supplier to Network Rail, which is really important to us, and we really enjoy working with them on projects like this. As such, NR has expressed an interest in trialling this, and the way we want to do it is a specific way, very simple, specific asset class initially, on a single route, and a clear value-add workstream alongside this. This is low risk and quick to implement. So the ask of the room, really, and what I'm looking for from the audience is, and how we go further on this is, if anyone in the room understands additional trial locations, different transport modes, and asset engineers and maintainers, we'd love to hear from you. I think part of this, which is really interesting, is this is not a solution that's limited to rail. If you have operations data, operational usage data, and asset data, a Bayesian model in the correct way can actually funnel that into a web system at the app. And I'm being flagged down with a big stop sign at the back of the room. So yeah, we're really interested in conversations, and thank you very much for taking the time to listen. Thank you.
Nice. Thanks so much. I just wanted to say that we're going to be taking questions as a group at the end as a panel. So think of your questions, put them on the Slido, and remember them. Thank you.
Hi, yeah, I'm Peter Ainsworth. I'm the CEO of Monorail. Monorail is a spin-out company from the University of Birmingham. And actually, I didn't realise he was going to be in the room today, but he's the chairman of the company is Professor Clive Roberts, and it's based on 20 years of his research at that university. So, oh, didn't know that was there. So today I'm going to talk to you about our use case for enabling predictive maintenance for railway track condition and geometry. A report by McKinsey suggests that moving to predictive maintenance approaches in railways could save up to 25% of maintenance costs. Network Rail spend about £1.5 billion per annum on track maintenance alone, and 18% of all railway delay minutes are caused by track faults and failures. Currently, virtually all railway networks operate scheduled and reactive maintenance approaches. It's difficult to move to predictive maintenance, as data is collected infrequently from expensive dedicated vehicles that run maybe once every 6 to 26 weeks, and data is often poorly located and requires multiple trips to site to identify the precise fault locations. Solving this challenge would address a number of government priorities by helping to significantly reduce rail maintenance costs, improve network performance, and passenger satisfaction. Our solution helps to enable predictive maintenance through collection of regular data from in-service vehicles, such as passenger trains and freight vehicles. It consists of 3 sensor sets, one fitted to the vehicle body, measuring ride quality, one fitted to the vehicle bogie, measuring track, and one fitted to the axle box that measures enhanced track features and vehicle wheel set issues. The sensors are retrofittable and modular, such that the deployment of sensors across the fleet can be adapted depending on the network characteristics. And you can see some of the fitments we've made already on the slides. We can adapt these so that the end user clients can measure to their specific requirements and their focus, be it track or train. These sensors collect track and vehicle data, which is transmitted to the cloud, where it is processed to provide real and recognized track engineering numbers and vehicle parameters. This data can then be visualized and further analyzed in a user front end. We both integrate with existing user front ends, or clients have the choice to use our own front end. We're currently working with Network Rail around integration of our data into their insight system. We're also able to accurately identify and locate rough rides and correlate them with track faults. And we've demonstrated that our system can be utilized to significantly reduce the application of speed restrictions. The volume of data we collect is large, and we're beginning to utilize artificial intelligence and machine learning approaches to process all this data, to provide track engineers with prioritized fault information based on the condition, the actual condition of the asset, that then goes on to aid actual proper decision making. We're also developing new algorithms that make positioning more accurate and automatically correlates rough ride exceedances with developing track faults. To bring our solution to market, we've been working with Network Rail to validate our data. As you can see on the right-hand side, the data is more than 98% comparable to the data collected from the expensive laser-based equipment on dedicated trains, where each system can cost more than £500,000. Monorail's system is a fraction of that cost. We have fitments on Eurostar and Eurotunnel vehicles and are working with them to further validate our data and develop a range of use cases that support the business case. We also have a fitment in Uruguay on the dedicated freight line to specifically demonstrate the technology on freight vehicles. Deployment of this solution across the network could deliver significant impacts for the UK railway. Firstly, maintenance savings. Network Rail could save up to £375 million per annum by moving to predictive maintenance. More effective and efficient resource utilisation. More effective decision-making will enable better use of resources and significantly reduce unnecessary engineering visits to trackside to simply identify fault locations. Improved network performance can be achieved by reducing Network Rail delay minutes caused by track faults and failures, and helping to reduce the length of speed restrictions. Finally, improvements in safety can be achieved through reduction in line-side working and reduced risks of train derailment. The ask for this audience is that we're looking to get into more regions of Network Rail, so we'd be interested in talking to anybody that can help us get into those regions. We're also looking to scale the business, so discussions with potential investors for that scale-up funding will be welcome. Thank you, and we look forward to talking to you in the future.
Thanks so much. Here's for our final pitch.
Any parents in the room? When was the last time you did the school run? I'm Maria Bennett, founder and CEO of Kigo. Also a proud mom of 2 amazing kids. Same street where I live, we have 5 families who do the same journey on a daily basis at the same time, twice, all in isolation. And I ask myself, why? Every school day, around 16 children either been seriously injured or killed on the UK roads, 16 every school day. Pollution increased by over 30% before 9 a.m., affecting our children's health. In London alone, every 1 to 4 cars is a school run journey, and it's cost billion and loss of productivity to the city and to the economy. So just in London alone, 7.7 billion just purely from congestion. And yet, if not the largest journey on a daily basis, that there is not a single tool to optimize or to share the journey, up until Kigo. Kigo Optimizer is a one platform layer that is come from a 3-layer platforms, giving the schools the ability to meet the climate action plans and emission reduction that's set by Department of Education last year. And then schools give a safe and secure access to the parents through a mobile app to share the school run journey, promoting active travel, walking and cycling, alongside public transportation in order to save cost and money and stress, and basically share that task of us as a parent to the school run. And last, what we also give is a layer of visibility for data to the local authorities and cities in order to optimize their home-to-school transportation that is constantly increased on an annual basis by 15% in the last decade. Send cost, which is over 2.3 billion pounds, and it's just go up. So reducing the home-to-school send cost alongside better planning when it's come to smart cities. Our go-to-market is we start with a group of schools that's strategically located in the city centers on a busy road where there is a complex journey that linking in and from to school. And then we go larger to scaling up to working with the local authorities around how we then optimize the entire transportation system, developing an AI. So what we do, we build, test, prove, and scale. Finally, we do all of that together with a partnership head of school science and psychology from Anglia Ruston University, who help us evaluate and create the frameworks for the AI engine. So what we do, we collect the baselines, and then based on historical data, the AI gets better every single time by able to optimize and predict and identify the best matches if it's through active travel, public transportation, and much more. And it just gets better. That's the beauty. Finally, we are a team of 7. We have expert in AI and traffic, public sector, cybersecurity, psychologists, and behavior science. And myself, I'm Maria Bennett. Before Kigo, I was co-founding a company called Teva Motors, zero-emission electric trucks. So I know how to scale from a vision to an execution, raise $150 million, 350 employees. Now used to decarbonize the transportation of delivering goods. Now I'm focusing on people and how we can then basically not just give parents the ability to share the school run, but also make our children healthier, reducing the congestion, the pollution, the emission, making the roads safer, and basically make a huge positive impact to the society, the environment, and much more. We are early stage, just under a year old. We're raising capital, 550K. SEIS and EIS are approved by the HMRC, and we're looking for collaboration with local authorities, city councils, best talents want to join the company, as well as raising the capital. So please feel free to reach out. Thank you so much for listening, and thank you for the opportunity.
Wonderful. Time just about to the second there.
I tried.
Pitches are getting good. Okay, so we've got a few questions in on Slido. I think I'll start with my first to yourselves at TrackBase. So in terms of Bayesian models, to what extent can they capture that kind of link between causality, in terms of actually what's going to break and what is going to get damaged by use? And how much are they just actually looking at kind of correlation, and how does that actually impact on real-life repairs, real-life maintenance?
Well, I'm going to do the diplomatic answer of I'm not technically competent enough to answer it, but my understanding of the Bayesian model and the way it works is It's very much the same as most modelling systems where, it depends entirely on what we put into it. If we have very good asset data and we have very good operational data, then the predictability and the probability of it is going to essentially align with what we want. And we know that we've done some looking at what you can actually put into context into Bayesian models as well, especially from the engineering side, which I think would be very useful for us. Because I think one thing that we don't want to do with what we're proposing is remove the engineer and the person in the loop. We don't want to remove staff. We want to basically make sure that the people that Network Rail have got can be aligned and go to do the jobs properly and do it in a more effective way. So I will defer the proper answer to that for now.
Thanks so much. That's really interesting, and yeah, it's definitely a challenging thing to conceptualize. But I think you did a really good job of putting that forward and what that's going to look like.
Thank you.
Okay, so moving on, Peter. So, question around how your systems would work on what unfortunately we know as being fairly spotty connectivity on the rail network. I know there's a lot of work going on to fix that, but how is it going to work when they're in tunnels, for example?
So our system works, we don't stream real time, partly because of cost. We could do if we wanted to. So we take off on a 4G network. The system buffers. We can use Wi-Fi. We've got the connectors in to do Wi-Fi if we wanted to. But the way the system currently operates is that if there's a 4G connection, it seeks that connection every minute. It packets the data up, sends it off on a 4G connection, goes up into the cloud processors, and they can generally visualize data in about 10 minutes. If there's no connection, then what happens is the system buffers, and the system can buffer data for up to about 16 days. So it'll buffer until it next gets a 4G connection. The worst scenario we've had is actually in Uruguay because we don't control the SIM cards. And so we've had a situation where we've lost data simply because they haven't topped up their data card. So as long as they keep their data card connected and paid for, then we'll collect the data just by doing it.
Yeah, makes a lot of sense.
Okay.
Yeah, it's nice to see you've got that example out there already.
Yeah.
Okay, so Maria, we got a question around behaviour change. Okay, so parents already know that public transport is an option, but often they choose not to use it. How are you guys going to drive that change?
So the culture in the UK is solo drive. So we used to primary, junior drive our children in from school on a daily basis. Just that's a fact. What we try is to create, and one of the challenges is around trust, and how do we then trust the other parents or the children or even the environment in from school. Now, here is the thing. What life change, like if people move to a different location or when they move from a junior school to a secondary school, all of a sudden the children need to start taking public transportation. And there is a lot of fears and anxiety around that, and there is not a way. So what we're trying to do is we're trying to work with the schools alongside promoting sustainable culture, why it's actually important to start walking or cycling. Why do we need to share the journeys? Because of the problems that it comes, and actually building a more resilient, independent generation where they can actually do those short distance independently to school and back from school. So that is kind of what we...
Thanks so much. That's really fascinating. Okay, I think we've probably got time for another question each, just about. So I think I'm going to go back to Peter. In terms of, hang on, I've lost the question here. Okay, so in terms of the sensors you guys have got, how can that be used for other modes?
Well, people ask us about cars. Unfortunately, the sensors, we've talked about automotive. In principle, it could be used. But the cost of our sensors is effectively too high. So the quality for rail, the quality of sensors that we've got is required in order to convert that information down into the actual track geometry numbers and the engineering numbers we have. There are lots of, in terms of roads, my understanding is that there are already people like TRL who monitor the network already have this type of stuff already on the roads. They don't necessarily need all the car data. And there are other solutions like your mobile phone that can already collect data around potholes and stuff like that. So the other area is potentially aerospace. but we haven't really looked at that at the moment because actually getting into rail is proving quite tricky anyway, even though it seems pretty much a shoe-in thing we should do. Trying to change the industry and get in there is really tough.
Okay, thank you. And one more for yourself. So in terms of the data that you guys are using, you seem very linked into Network Rail and UK infrastructure, but how applicable is that same system to potentially overseas rail systems, overseas infrastructure?
Yeah, no, that's a very good question. So I think in the UK, we're very lucky that we have now a very comprehensive performance database that Network Rail uses, which includes and is bringing in new things like, as I say, the consistent GPS data's in there at the minute. They're looking at integrating other data sources and making it the kind of go-to database. Network Rail obviously also has these databases around radar and ellipse. Having had a brief peruse at what they do internationally, we understand France has a very similar makeup of this. They have a split. They're pretty much down the middle. You have the asset data here, and you have the operational data here. So I think it's a very applicable solution internationally, in so much as we're not trying. I mean, with regards to TPI, yes, that is something we help Network Rail to develop, but internationally and in the UK, even if we hadn't done it, those data sources exist. The USP which we're proposing here is really the model and the output. So we just need those inputs. And as I said, I think internationally you could look at other transport modes. On a road system, an asset's going to be degraded. I mean, we know how many potholes there are in the UK. We're pretty aware of that. And we know that there's lots of, in certain, maybe a country lane, we know we're going to have a heavy tractor flow of traffic, and that data is available. So I think, yeah, it's definitely applicable internationally as well, and into other transport modes.
Oh, sounds good for the scaling.
Yeah.
Okay, so I've got a question that's been fairly popular for you both in terms of rail. How can you collaborate? You guys are doing fairly similar things, looking at asset maintenance, predictive maintenance.
Who's going to politely answer?
We provide you the data that you need.
Yeah, I mean, we don't. Yeah, it's a very obvious question. We don't work in hardware systems. We work in software exclusively in data analytics. You work in hardware.
Yeah.
So yeah, there's all these ways to do this. I mean, actually, I'm interested at the DFT day the other day. We did have people come up to us saying, "Oh, you seem to have a lot of access to Network Rail data. Can we see how it works?" And we're very open to that. And Network Rail, from our working with them, if you have the right people, are actually incredibly open with sharing their data sources. And the Rail Data Marketplace, I think, as Catherine said earlier, is a fantastic thing for this. If everything's going into there and also feeding in data from hardware, it's going to be really good. So yes, I think it's definitely possible.
Great, look forward to it. Okay, and just time for one final question for yourself, Maria. So what collaborations are you looking for?
So partnering with the schools, local authorities, any transportation providers, data optimization, network, and alongside the potential investors. So we are raising capital, SEIS and EIS. We want to build and change and break habits with regards starting with the school run, but our wider vision is basically focusing on how we can optimize the sharing the journeys. Building more roads won't solve the congestion and reducing the traffic on the roads. It will just create more. We have to become more responsible, and doing so with right tools, with right frameworks, and shift in the culture, sharing the journeys and make it more affordable and more sustainable is the way, I believe, not by building more roads and more bus lines. That won't solve the problem of congestion.
Okay, thanks so much. So can I get a round of applause for the panelists? So I think I've been asked to provide a few closing remarks, and I think I'd broadly say that these guys have come through a really, really tough process. There's been, I think, 3 rounds of judging to get them this far, including, difficult questions from the minister. I think these guys are really worthwhile having a discussion with, but I'll also say that we did extend the invite to the summit to all 10 people who came to the Dragon's Den and to pitch there. So there's even more people out there who are innovators worth talking to out there in the audience. So yeah, I think it's been a really good process. We're going to be working with you guys further to look at how CPC can support the businesses going forward. And yeah, I think this is really just been a great example of how government can support those innovators and support innovations and get them out in front of you guys. So thanks so much for coming, and yeah, look forward to seeing you guys in the lunch queue.